Hi dears, today we discussed about the series circuit. Today we discussed about the series circuit. Series circuit. Let draw a circuit with connected a source V and naming the resistance R1 and R2. When R1 is so connected to R2, the such type of connection arrangement is called series connection. That means the ending of the first resistance is so connected to the beginning of the second resistance. Such type of connection will be arranged is called series connections. In series connection, the current remain constant and the applied voltage V is the summation of voltage drop V1 and V2. V1 is equal to I into R1 and V2 is equal to I into R2. This is the total voltage drop. The total voltage drop will be V1 plus V2. Total voltage drop. Total voltage drop is equal to V1 plus V2. Let the total voltage, that means V is equal to V1 plus V2. We have to give the supply voltage V, and this is the drop V1 across the resistance R1 and across the resistance R2. So we know that V1 is equal to I into R1 plus V2 is equal to I into R2. So that the taking I is common, R1 plus R2. So V is equal to I into R1, I into R is equal to I into R1 plus R2. I cancel. So R is equal to R1 plus R2. So this is the total equivalent resistance of the circuit. So what will be the total equivalent of the circuit? That means R1 plus R2. This is the total equivalent circuit. That means we have to write here RT. We have to write here RT. So that we have to write here VT. The total supply voltage VT. Total resistance will be R1 plus R2. Similarly, what amount of current will flow through the circuit? What amount of current is flowing through the circuit? So current I is equal to total supply voltage VT divided by R1 plus R2. This one we have to find out. We have to find out the current. That amount of current, that amount of ampere of current will flow through the entire circuit because the I is remain constant. Series circuit. Next, what is the power consumption in the circuit? What is the total power consumption in the circuit? Total power consumption in the circuit of VT, that means power consumed in circuit. That will be PT is equal to I square RT. So I square, that means let us take an example here. Let this is 5 ohm. Let this is R1 is equal to 2 ohm and this is 3 ohm. So R1 is equal to 2 ohm, R2 is equal to 3 ohm. So total resistance RT is equal to 2 ohm plus 3 ohm, that is 5 ohm. So let the voltage VT is equal to 5 volt. So this is 5 volt. So the current I is equal to 5 volt divided by 5 ohm total resistance. So total resistance किती? So what amount of total resistance? That is 5 ohm. We have to put here 5 ohm. So that is 1 ampere. So total current of the circuit, that is 1 ampere. That means total current, that is 1 ampere. I is equal to 1 ampere current is passing through R1 and R2, because that amount of current I is equal to remain constant. So what will the voltage drop? The voltage drop V is equal to I into R1. So I value, the value of I is equal to 1 ampere and R1 is equal to 2, that is 2 volt. And what will the voltage drop in resistance R2? So V2 is equal to R into R2. So that 1 amperes into R2, that is 3. So that is 3 volt. So total voltage will be 2 volt plus 3 volt is equal to 5 volt. 5 volt we have to apply. 5 volt we have to apply. Clear? So what is the power consumptions? What is the total power consumption? What is the total power consumptions? Total power consumptions. Total power consumption how much? So total power consumption, that means P is equal to I square R T. 1 amperes squares into RT. The RT is equal to 5 ohm is equal to 5 watt. The unit of power is equal to watt. Unit of power is equal to watt. Clear? Thank you, guys. Next problem will be parallel circuit. Next we have to discussion about parallel circuit. But in series circuit, the total resistance will be additive in nature. Total resistance will be additive in nature. This is the total resistance. This is the total resistance. RT is equal to R1 plus R2. But here the current I remain constant and the voltage drop is different. The voltage drops are different. It is a single path. It is a single path or single branch. One branch is there. It is a single loop. It is a single loop. A single loop, because the current is passing through one way. The current is passing through one way in the single loop. It is no junctions. It is no junctions. Single branch. Clear?